And under parallelograms, please, we are talking specifically about angles, areas, everything you want to know about parallelograms is what we're afraid to ask. I suppose, do I have a parallelogram on these? Please say yes. I do. Well, we'll just draw in here. Best we can. Remember, a parallelogram has two sets of opposite equal, well, they'd be equal parallel sides. Best I can do right here. Now, when we're talking about parallelograms, rectangles are parallelograms, but let's just say that they're the squished rectangle sort of right now. That'll help you out. Now, a couple special things you have to know about them are that, first of all, just like any quadrilateral, all inside angles, God bless you, angles add up to 180 degrees. Just like, I'm sorry, that should be 360. I was thinking triangles. 360 degrees. And you would know that for sure because if we did look at a rectangle, which is a type of parallelogram, every angle in a rectangle is 90 degrees, correct?
Yes.
So if you have four 90-degree angles, it's 360. Okay? Now these won't have 90-degree angles. They'll have, this one's like, this is an obtuse angle, that's an acute angle. The other thing to know about parallelograms is that the opposite angles are equal. You can amaze and whatever your friends. And what does it mean by opposite angles? Well, that means this. This angle is opposite of that angle, and this angle is opposite of that angle. Which means if you all you need to know is one single little angle, and you can figure out all the rest. For example, if this was 60 degrees, let's say this is labeled A, B, C, and D. If angle A is 60 degrees, then you know because the opposite angles are equal that angle C is also 60 degrees because they're opposite. Gosh, I should quit. Angle C is also 60 degrees. Now what about angle B and angle D? Well, ladies and gentlemen, here's kind of what you need to understand. My two 60-degree angles give me how many angles so far? 60 plus 60 is 120. I know there's 360 degrees. I already have 120 in angle A and angle C. That leaves me with just 240 degrees left. And I know that both of those angles have to be equal because they're opposite. So what would each angle have to be? I would cut those both 240 in half, and each angle would have to be 120 degrees. So these would have to be 120 degrees. You can go home and amaze your parents with all this kind of handy-dandy info. Now, one other thing that you might see, maybe you can see it there or not, anytime you have angles that are next to each other, like 60 and 120 and 60 and 120, or 60 and 120 and 60 and 120, guess what they have to add up to? Frankie? No, that's the total angles. I'm looking at just, if you just put together these angles, or if I put together these angles, or if I put together those angles, if I put those angles together, Zach, it has to add up to, yeah, angles next to each other. Angles next to each other equal 180 degrees. They have to form a straight line actually, but that's the so just, let me draw another one. What if my parallelogram looks like this? Which is really small, isn't it? Forget that. Let's go big. I really wish I would have had one. So here's my parallelogram. If you knew that this was 150 degrees, which it's not, but I can tell you right now that this angle here would have to be how big? Have to add up to 180 degrees, so that angle has to be 30 degrees. Let's not overthink the whole spiel, but that's what it would be. And this angle here would have to be 150 degrees. And this angle here would have to be 30 degrees. Just the way it works. Is that not exciting? Now, the next thing we're going to talk about with parallelograms is the area of parallelograms. And the problem with areas of a parallelogram, I am going to see if I can learn my way through this really fast. Stay focused here, kids. I'm going to go to 7th grade math. Yes. Did I mention 7th grade math is hard?
Yes.
Okay, you should be scared.
I know.
Especially if you don't. What is 7th grade? 7th grade is somewhere at 62, so give me something in the 50, late 50s. There we go. Oh, look at that bad boy. I'm going to copy and paste this. For you kids. Here is the deal with parallelograms. Well, that didn't work. Let's take a look at this parallelogram. Slap it in here somewhere. Alright, if I asked you for the area of that parallelogram, okay, you have a small problem here. You could try to count the squares, but, well, how many squares? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is 15 units this way. And the problem is this. First of all, if I did know this, let me just make up a number. Let's say that number is 13. Wait, let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know this has to be longer than 10, right? Because 10 is straight up and out. Let's just say this is 11. Just like we've done triangles, have we not? We've done area of triangles?
Yeah, no.
Really? Okay. All right. If we're doing area of parallelograms, I should just tell you here. Well, hold on a second. Let me go back to where was I? I'm going to go back to here. Bear with me for just 1 second. I don't know. Ready? Oh, no. Maybe 2 seconds. The way things are working here. Maybe.
Can you please come to the preschool bathroom?
No. I'm gonna go. Wait, I think I've got it.
Oh, yeah.
We'll call that good. I'm not going to here. Here's the deal, ladies and gentlemen. The problem with finding the area of this is you cannot do, it's not a rectangle and you cannot, it is not length times width. Just take my word for it, it's not length times width. What it is, however, is this. If I were to cut, let me get this the same size. If I were to cut, if I were to take this one side like this, cut it like this, slide it over here, oh no, it doesn't work. Well, maybe pretend like you can still see the yellow there.
Oh, I can see through stuff.
Just pretend. Why can't I get mine?
I like. Are you trying to
Not,
come?
sorry. Let me get rid of this. Which means I have to get, this is what I cut out, right? I can make a rectangle out of it if this was not there. You can see it's all one big rectangle. And what would the area be? Well, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is 15 units on the bottom. But the top is not that 11 units that I had for this. The top is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the area of this, which you would say that is length times width, it is not. Okay, write this down because this is the area of a parallelogram. Area of a parallelogram is base, you sure we didn't do triangles?
No, sure.
Times height. To which you are going to ask, by the way, here's the abbreviation of it. A equals B, I'm sorry, A equals BH, or B times H. To which you're going to ask the question, what's the difference between length and width and base and height? Somebody asked the question.
What is the difference between length, width, and height?
Base, in math, when we use base and height, these two things have to be perpendicular or they have to form a right angle with each other. They have to form a right angle with each other. Anytime in math, you're asked to find the base times the height. Okay, those two lines have to form the right angle. So that means this. I need to get back out of this. Okay, if you are given a parallelogram and they tell you that this is 8 inches and they tell you that this is 6 inches, you cannot find the area of that parallelogram based on the information you are given. Why? Because if the formula is area equals base times height, and these two have to form right angles, this is not a square corner. You can't use those two lines. You will have to be given one more dimension, and the book a lot of times will put a dashed line like this, and they'll give you a little square corner, and they'll say this is actually 5 inches. Now, what is the area? You would then multiply the 8, which is the base, times the 5, which is the height, and the area would be 40, whatever it is, units squared. You are not allowed to use this because it does not make a right angle. Now, why does it work for rectangles? Because everything in a rectangle is a right angle. You know, if you had a 6 and an 8 here, those already form right angles, so you can use length times width there. But when it's a parallelogram, you have to do base times height. Okay, and it could, maybe they do it like this. They might tell you that this is 12, and they might bring a line straight down from here and extend this line here. And they'll say this is 8. So my area of that would be 8 times 12, base times height. And it would be 96 inches. Now you might need to know these other dimensions to find perimeter. Perimeter would be 8 plus 6 plus 8 plus 6. But to find area, you are always, always, always going to be given that square corner there. Does that make any sense? Despite my poor attempt to do. Look at page 371, please. Well, I guess we didn't talk about this. You maybe have to go back to this page here for just a second. Anytime two angles form 180 degrees, we call them supplementary. Let's write that in there. Supplementary. Supplementary angles form 180 degrees. Which, by the way, 180 degrees is also a straight line, remember? That is 100. So, back to page 271. Let's see if we can't muddle our way through this. Look at the practice part there. Letter A says, which angle is opposite angle Q? Looking at that parallelogram, that is ST, Q, and R. What angle is opposite of Q? I got one taker here. Eddie? Angle S. Very good. What angle is opposite angle T for letter B, Victoria?
R.
Very good. And then it says, letter C says, name two angles that are supplements. Supplement. Oh. Yeah, you have a whole bunch of choices. What could be? What angles form 180 degrees? Give me one, Zach.
SR.
Yep, angle S and angle R, or angle S and angle T, or angle Q and R. Now, here's letter D. If the measure of angle R is 100 degrees, what would be the measure of angle Q? Frankie?
80.
Why?
Because they have to be 180 degrees.
And then the letter E. If you were asked to find the area of letter E, what two numbers would you multiply together for the area of letter E? Tyler?
10 and 8.
Why 10 and 8? Because they form right angles. What would you add together to find the perimeter? The distance around you would add together. Jordan Shaw? Yes? No? No? Distance around is add all the sides. And the dashed lines don't count for the sides. So Julia, it would be?
8, 8, 12, 12.
Right, 8, 12 plus 8, and 12. That shape. You don't count the dashed lines as being part of its perimeter. It's more like this. This was 8, this was 12, this is 8, that would be 12. This is not part of the shape. It just gives you this dimension. So you'd only add those parts together. That is not part of the shape. And, well, what two would you multiply together for letter F to find the area? Colton?
5 and 8.
5 and 8. And what would be the perimeter by adding what, Victoria?
8 plus 8 plus 6 plus 6.
There you go. Everybody kind of got a firm grasp of reality there. Whew. Failure.